Math 1343, Review, Standard Normal Distribution, Z. Video 1, Parameters for a Normal Distribution. In an effort to get all of these students in my Statistics 2 class on the same page during this first week of class, we're going to spend some time reviewing some topics from Statistics 1. As I mentioned in class, how you saw this topic presented to you is heavily dependent upon where you took Statistics 1, who taught it, and what textbook was used. As we mentioned in class, statistics is a little bit of a bizarre subject, at least at the early level, because the emphasis can be completely different in two different textbooks that could be used for the same course. So we're going to spend some time getting us all on the same page. Hopefully most of the things, if not all of them, you'll recognize, if not flat out remember. Let's start with what actually makes a standard. I just noticed a typo after I just spent some time reviewing this to make sure I didn't have any. But let's kind of review what exactly makes a normal distribution normal. Don't panic if you don't recognize all the words yet. A continuous quantitative random variable has a normal distribution. This is what we're defining, so let's underline it. Has a normal distribution. Trying to make my name disappear. Not sure why it's there. Let's try something here. Hold on, folks. There we go. All right. A continuous quantitative random variable has a normal distribution with mean mu and standard deviation sigma if the distribution of values has a bell-shaped curve with center mu. Got some dots floating around there. Let's see if I can make them disappear. There we go. All right. So let's just talk about some of these words real quick, and I'll highlight them as we talk about them. In theory, these are words that you're already familiar with, but for some of you, it might have been a while since you've seen some of them. Let's start with the phrase variable. A variable is just a aspect of something that you're measuring. How tall are people? How many kids do people have? What color are people's hair, or things like that. A random variable is a variable whose value is determined by a random experiment, such as choosing a name at random and asking them how old are they, or flipping a coin and seeing if it comes out heads or tails. A variable is quantitative if what it's measuring is numerical, so to speak. Specifically, you're measuring a quantity whose numerical value means something. For example, if I ask somebody, how many cats do you have? That's a quantitative variable. If they say 3 cats, that means something. As opposed to something like if you have a football player and you ask them, what's your jersey number? And they say 21. That number 21 really has no quantitative meaning. It's simply a label. So not all numerical variables are quantitative. Most of them are, as long as the number is actually referring to a quantity. And a continuous variable is a variable that can assume any value between two given values. Think of it this way. A continuous variable can be measured, usually with decimal point accuracy, as opposed to a discrete variable that doesn't measure, but rather counts. If I asked you how many cats you have, you would count. That would be a discrete variable because your answer would be a whole number, and it wouldn't make sense to say something like I own 1.7 cats. Whereas a continuous variable, continuous quantitative variable, is one that you can measure with certain amount of decimal accuracy. For example, if we wanted to measure how much water was in this bottle of water, we could pour it into some measuring device and measure it using decimals, as much accuracy depending upon the measurement tool that we have. So easiest way to think about it is that continuous variables you can measure with as much accuracy as whatever your measuring device allows. All right, I assume we all remember that mean is pretty much average, and standard deviation is a measurement of spread, how spread out a data set is. There is a formula for standard deviation, which we won't go over right now. All of you should know that mean means average, so we're good there. But again, this whole paragraph is the technical definition of what it means for a continuous quantitative random variable to have a normal distribution. Technically speaking, and this goes way beyond what this course needs to do, but I just wanted to let you know that this isn't just some random picture somebody drew. Technically, such a distribution, if normal, if its probability density function is of the form 1 over this f of x equals 1 over the square root of 2 pi sigma, where sigma is your standard deviation, times e to the negative x minus mu squared over sigma squared. Now, there's a good chance you've never seen this function, and honestly, you don't even need to see it now. You're not going to have to worry about this. I'm just letting you know that a bell curve is just a graph. And for those of you with some algebra background, which is probably all of you, most of you know that graphs have functions that can generate them, or rather a function can generate a graph. I do want to show you real quick what this graph looks like in a website called Desmos. Some of you may be familiar with Desmos. It's a really nifty website where you can do some graphing, but you can do so much more. I happen to have an equation, a function already set up for this bell curve. Here's that function I was telling you about, which you actually won't have to worry about. I can't type Greek letters here, but I used M for mean and S for standard deviation. I've got a slider here that I can move back and forth to change the mean, and an S slider that I can move back and forth to change the standard deviation. You'll notice that the mean 0 is currently in the center of this curve. But if I were to move the mean greater, like let's move it up to 1, then notice that the center of the curve is now at 1. And no matter where I move the mean, it's just sliding the curve left and right. We'll put it back at 0 just for now. The standard deviation is a little harder to visualize. I do have some marks here separating 1 standard deviation from the mean to the left and to the right, 2 standard deviations from the mean to the left and right. You can't see it because of how narrow it is, but there's one for 3 standard deviation means from the mean to the left and the right. But the standard deviation kind of measures how spread out your data is. So for example, if my standard deviation was larger, my data would be spread out more and my curve would be flatter. So watch what happens as I raise the value of the standard deviation. See those lines here moving to the left and right? Those represent 1 standard deviation from the middle. And so as I increase the standard deviation, the curve starts to flatten out some. And vice versa, if I reduce the standard deviation to less than 1, now the data isn't spread as much, so it's more compressed in the middle, which is why the curve is actually getting higher. All right, let's put this back at 1. All right, so that's the technicalities of a bell curve. But again, all you really need to know about a bell curve, about a normal distributions curve, is that it's a bell curve, and the center is always the mean of this distribution. All righty. So what makes a normal distribution standard? Because if we go back to the beginning of this Zoom recording, if you will, we're reviewing a standard normal distribution. The word normal in standard normal distribution means bell curved shape. But if you see the word standard in front of it, standard normal distribution, then that has some very specific parameters, the parameters being the mean and the standard deviation. So what makes a normal distribution standard? Number 1, the mean is mu equals 0. And number 2, the standard deviation is sigma equals 1. I'm assuming everybody remembers that mu is the variable for population mean and sigma is the variable for population standard deviation. If you didn't remember that, you might want to write it down. Mu is the variable for population mean. Sigma is the variable for population standard deviation. So the phrase standard normal distribution is very specific. If I ask you on your first test, what makes a normal distribution standard? The answer is mu equals 0 and sigma equals 1. So going back to Desmos for a second, you might recall that when we were in Desmos, this bell curve, this normal distribution actually started with a mean of 0 and a standard deviation of 1. So what you're looking at here is actually the standard normal distribution. I'm going to zoom in on it just for a second because I want to show you that there's actually more over here. It's just that we were zoomed in so much you couldn't see that tail. Theoretically, this tail goes forever, as does the one on the right. But by the time you've gone, let's go back to the home. Oops, that's not what I want. Looks like let's see if I can put it back the way it was. I'm just undoing with Control Z. There we go. My train of thought derailed. If you're a normal distribution, your tails technically go forever. There was something else I was going to say, but that train of thought derailed when I was trying to get it back to this picture. Oh, well, if it's important enough, I'll remember it and say it later. All right, let's go back to the whiteboard and Zoom. All right, some advice about drawing bell curves in this class. When you draw a normal distribution curve, notice I didn't say standard. You should always label the center with the value of the mean. You should also indicate the standard deviation. So for example, let's say that you have a mean of 10 and a standard deviation of 3. This is what I want you to do when you draw a bell curve for such a normal distribution. If the instructions were draw the bell curve, it doesn't have to be perfect, but in the middle, you should put whatever the mean is, and somewhere you should indicate the standard deviation. I will usually just indicate it up here. It doesn't matter really where you put it. What some books will advocate is go one standard deviation out and put a mark. And that's not necessarily wrong, but there's a lot of numbers to the right of 10 besides that one. That's 3 to the right of 10. 3 to the left of 10 would be 7. But that's what I'm going to want you to do when you draw a bell curve in this class, to put the mean in the middle and indicate what the standard deviation is, assuming that you know it. Now, when you draw a standard normal distribution curve, and honestly, I should say the standard normal distribution curve, because there's only one, because standard means mu is 0 and sigma is 1. Standard means the mean is 0 and the standard deviation is 1. So there's only one such curve. Now, I guess how far zoomed in or out could vary, but being a standard normal distribution, its mean is 0, so you put it in the middle. But if you don't write a standard deviation, in other words, if you don't write sigma equals 1 and there's 0 in the middle, it is presumed that it is a standard normal distribution curve and the standard deviation is 1. So it's okay to write sigma equals 1, but if you don't write it and you put 0 in the middle, I assume that's what it is. All right, in the event that you are simultaneously referring to a normal distribution and a standard normal distribution in a single setting, this will happen. Label the bell curve with the normal distribution's mean and standard deviation, but draw a number line below the curve with 0 in the center. This allows 2 number lines for the curve, one for the normal distribution and one for the standard normal distribution. In other words, let's say that we had the curve we had before with a mean of 10 and a standard deviation of 3. If I were in a setting where I also needed a standard normal distribution curve, a common gimmick is to draw another number line underneath it and put a 0 in the middle. Now, in the event that you do this, you should label the bottom number line with the variable z, the variable for the number of standard deviations from the mean, which we'll talk about in a subsequent video. But you should also label the first number line with whatever variable is being referred to. The generic variable is x. Because in most statistical settings, normal distributions are not standard. They're anything but. But when we do calculations, we standardize them, so we need a number line referring to the standard normal distribution. All right, so again, all this is saying is that if you're drawing a bell curve for a setting where that's not standard, either the mean is not 0 or the standard deviation is not 1 or possibly both, then draw the normal distribution's bell curve with its mean in the middle, indicate its standard deviation, but below it, draw a standard normal distribution curves number line with 0 in the middle. And I believe that wraps up this video. All right, in the next video, we're going to talk about what Z means, and we're going to talk a little bit about the relationship between probability and area under a curve.